video is about piecewise functions. Our essential question is, how do we graph piecewise functions? A piecewise function is a graph or function made up of pieces of other graphs or functions defined by their domains. The domain itself is what cuts the function into smaller segments or portions. And so being able to identify and correctly apply your domain is very important. Now, we're going to look at a couple of examples. And in these examples, you'll want to be able to fill in a table. And you can see how I have the table set up for you already. Some categories that you want on your table are function, x values, computations, to figure out what y is, and then what is your y value, and then making an ordered pair out of those values. So the first thing we're going to do is figure out what values of x that we need. You'll notice the function is one of the two that's listed here. We got x squared minus 1, we got 2x plus 1. Now looking at your domain, the domain kind of gives you an idea of what x values to choose. We have an x value of x is less than 1. 1 is a critical point, so I'm going to make sure that it's in the table. I'm going to put a box around it, and then I'm going to choose some values that are less than 1. -2, -1, and 0 all fit the bill. For my second function, absolute value of 2x plus 1 tells me that the domain is x is between 1 and 4. So once again, on my table, I'm going to include the two values, 1 and 4, in my table. And then I'm also going to pick some points in between. After I've chosen my x values, now I'm going to compute the y values that result from those. So I'm going to put pause, and then I'm going to fill in the table. You go ahead and fill in your table as well, and then we'll check back. Okay, you'll notice for the first part of the table, we came up with, when we plugged in -2, we got a value of 3, so there's our ordered pair. -1, 0, 0, -1, and 1, 0. Now the next thing I need to do is figure out what kind of point each one of these is. The ones that are located at the critical points of our domain, we have to decide whether it's going to be an open or a closed circle. Because this is less than and not less than or equal, it will be an open circle. So at 1, 0, I will have an open circle, and at the other values, I will just have regular points. So when I come over here to the graph, when I graph this, -2, 3 is located here, -1, 0, 0, -1, and then notice at 1, 0, I have an open circle. Now I go down to my second part, fill in the table, and we'll come back in a moment. Okay, looking at the second part of our table, we plugged in 1, so we ended up with a value of 3 for that. On our second one, we had 2, 5 as our value. On our third one, 3, 7 as our ordered pair, and 4, 9 as our last ordered pair. Now again, 1 and 4 were our critical points, so when we come up here and look at our domain, we can see that 1 is associated with less than or equal to, so that's going to be a closed circle, so it needs to be colored in. And then 4, again, has a less than symbol, so that's going to be an open circle because there's no equal. So over here, I have a closed circle at 1, 3, and at 4, 9, we have an open circle. And the points in between are just regular points. So when we come over here to graph it, 1, 3, closed circle, 2, 5, regular point, 3, 7, regular point, 4, 9, open circle, and we just connect all the points in between. And this is the completed piecewise function. F of x equals x squared minus 1 if x is less than 1, absolute value of 2x plus 1 if 1 is less than or equal to x is less than 4. Now we're going to move on to a second example. And and go ahead and pause to copy this example down. Okay, for example 2, we have graph f of x equals square root of 2x minus 3 for x is greater than or equal to 2. X for 0 is less than x is less than 2, and x minus 2 squared for x is less than 0. So you can see on the table, again, we have the same categories: function, x values, computations, y, ordered pairs. For square root of 2x minus 3, our domain is numbers that are bigger than or equal to 2, so I chose 2, 3, and 4. For x, our values are between 0 and 2, so I chose 0, 1, and 2. And then for the last one, x minus 2 squared, a little typo here. For x is less than 0, I chose values -3, -2, -1, and 0. And again, the ones that are boxed are my critical points, so we'll go back and evaluate those in a minute. So the next thing we need to do is fill in our table, and then we will come back and plot our points. So go ahead and pause and fill in your table. Okay, for the first function, square root of 2x minus 3, we have the point 2, 1, 3, 1.7, and 4, 2.2. And if you look at your domain, 2 was our critical point. The symbol is greater than or equal to, so we're going to have a closed circle at 2. So 2, 1 is a closed circle. And then 3, 1.7, and 4, 2.2 are just regular points. So go ahead and plot those, and then make your graph. And so your graph should have looked like this. Okay. Now we're going to move on to the second function, x, when the number is between 0 and 2. It's just going to be equal to x. So the first one is 0, second one is 1, third one is 2. Go ahead and set up your ordered pairs and graph. Notice that 0, 0, 0 was associated with less than, so that's an open circle. 2 also had the less than symbol, so 2 is also an open circle. 1, 1 is just a regular point, so we come and plot those. 0, 0, open circle. 1, 1, regular point. 2, 2, open circle. And we connect in between, and we have that portion of our graph. Now we're ready for part 3. X minus 2 squared. For x is less than 0, go ahead and fill in your table and see if you can plot your points. Okay, notice for the last one, we have the point -325. I don't think we want to have to graph that one. Second point, we have -216 when we work it out, and third one we have -19, and fourth one we have 0, 4. The first three are all regular points. The last one, 0, is one of our critical points. Less than means it's going to be an open circle since there's no equal sign. So let's go start plotting these points. 0, 4 is on the y-axis at 1, 2, 3, 4, open circle. The next one, -1, 9. If we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're over -1, that's going to be a regular point. And then you'll notice that -216 is going to be way up there, like way up here on the graph. And so this is, if you recognize, it's got the square, so this is a quadratic, so it's going to have that curve shape to it. Basically half of a parabola. 25 is way off the graph. So this is what your piecewise function should look like. You've got your square root portion, and then you have your linear portion, and then you have your parabola portion. And that is all. If you have any questions, come in the morning and ask. Thanks. Make sure you get it all in your notes. Have a good evening. Bye-bye.